In this video, we are going to talk about applications of exponentials and logarithms. So let's review a few key important details. We need to remember how to convert between a log and an exponential equation. So remember, the base of the exponential is the same as the base of the log. The answer to the exponential goes with the base to the log. And then my exponent is always going to be the answer to the log. Some other things to remember is that when we have a log with no base, or appears to have no base, it's technically a log base 10. And anything that's a log base e, we're actually going to use our ln button for. So we'll talk about that a little bit today. So these formulas should look really familiar. They're the same formulas we used back in our exponentials unit. So if we read this first one, it says an investor puts $25,000 into an account that has 2% interest compounded annually. He waits 5 years, how much money will be in the account? So this problem is really similar to the problems we did last unit. We're going to use our compound interest equation. My principal, or how much I'm putting in the account, is $25,000. My rate is 0.02. Compounded annually means my n is 1, and my t is going to be 5. So I'm going to put all these numbers into my equation. Remember to do your exponent first, so 1 times 5 is 5. Then I can just type this whole thing in my calculator, and I will get that. I get $27,000, $27,602.02. Now this is where we're going to do something a little bit different. Now it's asking for how many years. So now we're going to solve for t. Will there be approximately $30,500 in the account? So now they're telling me how much is going to be in the account. So they're telling me my a value. So I'm going to have 30,500 equals 25,000. 1 plus, now all the rate and the compounding is going to stay the same, but now I'm going to leave t in my equation. So in order to solve for t now, I'm going to do some simplifying. So first I'm going to simplify what's in my parentheses here. So 30,500 equals 25,000, and I'm at 1.02, and I just type this in my calculator. And then 1 times t is just t. Now my goal is to get this part with the t alone. So to do that, I need to divide by this principal amount. So I'm going to divide by the 25,000. And when I do that, I'm going to have 1.02 to the t power here, and it's going to equal 1.22 on this side. Now, we are going to use our log conversion. So remember, when I have an exponential equation, y is equal to b to the x. Now to convert this to a log, it'd be log base b of y equals x. So this is going to convert into a log, and it's going to convert into log base. Well, my base is 1.02 of 1.22, and it's going to equal my time. So I'm going to type that in my calculator. Remember, if you don't have a TI calculator, you want to do the log of the answer divided by the log of the base. Either way, this is going to get us 10.04 years. And so this is what we're going to be focusing on today, is kind of the difference between solving for the amount in the account and how many years it takes to get to a certain amount in an account. All right, let's take a look at number 2. Number 2 says $320 is invested in an account that pays 3% interest compounded continuously. So on our other side, we had all our formulas, and so PERT is the formula that we use when we're compounding continuously. So again, my P is going to be $320 because that's how much is invested, or again, put into the account. My rate is going to be 0.03. Compounded continuously, again, just tells me I'm using my PERT equation. And they're telling me after 12 years how much will be in the account. So again, I'm solving for A in example in this first part. So A equals PRT. A is going to equal $320 E to the 0.03 times 12. Now again, we want to do that exponent before we type in the calculator. So I'm going to do 0.03 times 12. I'm going to get 0.36. So now I can just type this in the calculator, And I will get that. If it's compounded continuously, I'll have $458.67. All right, so now they want to know after how many years. So again, now we're solving for t. Will that amount double? So my original amount was $320. So now the amount that I want in the account at the end is double that, so $640. So I'm going to use my same formula. I'm going to put 640 in for A, 320 in for P. My rate is still 0.03, and then the T is what I don't know. I don't know how much time it's going to take. So similarly to the first example, I want to get this part with the exponent alone. So to do that, I'm going to divide by this value in front. So 320. So 2 is going to equal e to the 0.03t. Now again, we're going to change this into logarithmic form. So logarithmic form will be y equals b to the x is the exponential form that it's currently in. And I want to change it into log base b of y equals x. So what is that going to look like? We're going to have log base e of 2 equals 0.03t. Now, log base e, we talked about this on the front page. Log base e is the same as ln. So I'm just going to take ln of 2, and on your calculator, you just want to look for the ln button, which is right next to your log button. So I'm going to type in ln of 2 in my calculator, and I'm going to get 0.69 equals 0.03t, but I don't want 0.03t, I want how much time. So I'm going to divide by 0.03. I'm going to get that t is 23 years.